Hello and welcome back to compiler programming. It is time finally to start working on the register allocation, and that means that there will be lots of changes that need to be made to make sure that we are not just randomly using registers, right? So for example, things like these should no longer be a thing, right? I should not be able to just say, oh, give me this register A specifically, and I'm going to use it as a temp register. So we will need to say, oh, I just want a temp register. And the system should be able to figure out what is the right register, maybe move some values to the stack, put them back in registers, so this kind of stuff. We do need to start somewhere, and I guess we can start by creating a function that will actually do that. I'm not sure where would be the best place to put it. Let's just put it here for now and then figure out how to deal with it. So we would have a function that would be something like, I don't know if it should give us an operand or it should give us a value directly. I guess let's start with just having an operand, and here is find temp, or not find, maybe allocate temp register or acquire. Allocate is a bit too specific to the memory. So acquire, maybe not temp. I just say acquire register, and then there will be acquire temp register, and they will be slightly different. So this thing will need to have a pointer to code block because it will need to deal with the stuff there. And let's do the second one, right? So we can say that acquire register and acquire temp register. So this one will need to receive a register index, I guess. So I definitely need to improve how we deal with floats versus general purpose registers, so XMM versus regular stuff, because right now they share the enum values within register, and it's not really great. We can't really easily distinguish them, but this is not the purpose of today's video. So for now, I'll just focus again on general purpose registers because our tracking of registers is not ready for XMM anyway, right? Okay, so how will this work? I guess we would say if let me mark this and go to function encode and look at how this is done here. Yeah, so we'll need to do something like that as well. So let's take that stuff, go back here and figure out. So here there will be an array or loop, and here we just want to get one, right? So we have operand type register, byte size is an interesting question. I guess I should pass the byte size into here, and I would say U8 byte size. I don't know what is actually the size of it in operand. So byte size is U32. Well, okay, then I guess that's what we'll use here as well. Byte size, we can assert here that byte size is 1 or byte size is 2 or byte size is 4, our byte size is 8. Although here, I guess it's fine. Okay. Register bit set, get result. So we want to say that if it is so in this function we will be doing the following. If the register is occupied, then we will save the value to the stack, I guess. The trouble I see right now comes from restoring that value back, right? So if we decided to store a value in the register and then we had to move it out to the stack, then we have a bit of an issue tracking that within the scope later on. So one option would be for now to never assign values to registers permanently. So what I'm saying is, like, if you do something like this here, then it's very likely that the compiler will actually just put this into the register straight away and never assign it to a stack location. But in order for us to do that and being able to do like acquire registers at some point, we would need to know when this happened, right? When we evicted it from being a register to being in the stack. And I definitely need to read more about register allocation. It's a very extensive topic, and what complicates matters more is the fact that I'm sort of trying to do it in a more like in kind of one pass way, where traditionally it's more graph based setup, and it's quite complicated. Anyhow, for now I think for temporary registers it's okay to it's okay to do it this way, but what I'm thinking is now that we won't even do this version of the function, instead we will do this this version. And so basically, if we cannot find an empty register, we'll just crash for now. And that would be how we deal with this problem. So let's just do the basic version. So we go through the registers, and it's an interesting question. For example, what is the best algorithm here, right? Should I try to give you out first volatile registers? Should I try to give you out non-volatile registers first? Like, what is the best approach? And I don't know. What I can say is that we can try different things and see what works best. For now, let's get over with the basics. And okay, operand here doesn't really matter what we use. Temp. So this will be necessary when we allocate. So this is actually what we'll do here. We'll say that we will use it, and then it actually means that we need function builder here, not code block, which is also good to know. So we say set. Okay. So we are marking this as being used. And here we would say that if register occupied something like this. Test temp, I don't know. It's gonna be called operand very unimaginatively. So for now, I will ignore whether the register is volatile or non-volatile. I will just say, okay, look, if you're unoccupied, I'm gonna get you. Although I'm wondering if that will cause issues with calls, but we'll see. So if we found a non-occupied one, we say it was used. We also need to say that it is now occupied, and we return rec index. Here we can say, I don't know, and we'll see panic could not acquire a temp register. Obviously this is not viable long term, but for now this is fine. And we will need another function, which is like, I guess, release. Maybe I should name them, I guess, temp register acquire, temp register release, function builder. This will get a register. And first we will assert that we actually using it. So we would say that it is occupied right now. I'm starting to slightly regret how I did this stuff. So yeah, I will definitely need to make another pass and change this register enum to have separate values for XMM and non-XMM. That will also help get rid of this stuff here, I guess. So yeah, that's something to do. For now, that's okay. Okay, so that builds, and we are marking it as unoccupied. So remember that for used register bit set, we never unmark it. We always say, like, if it was once dirty, we need to keep it there because that's what tracks pushes and pops for our non-volatile registers. But we can now say that it is actually, we don't have unset. So that's something to do. Register bit set unset. Yeah, we definitely missing this operation, and this is where I'm not very good with bit patterns. So let me make sure that I do it right. So we have, for example, 1 shift by 4, right? And this gives us this pattern. And now I want to bitwise not it. Then this should turn into a mask. Yeah, it did. And then I can use this as the mask. So I think it's like this to clear a bit, but you know, don't quote me on that. Let's see if that actually works. Okay, so we have our set, we have unset, that's fine. And we can try to use it at some point. So where shall we use it? XMemo is not yet working, so that's not something we can do. But here we can try to actually use it. And we can say operand temp is temp register acquire of builder. So we are moving it to temp and we're moving it from temp. And now we can say temp register release of temp reg. Oh, huh? So actually I do need value register for descriptor. Actually it should be operand, honestly. So that's another thing to do. Add operand register for descriptor. But for now, again, we don't care. And descriptor is what was that? Target, I guess. Was it the right thing? Yeah, target descriptor. Good. Value star. And I have to again do this stuff. So yeah, definitely need operand register for descriptor. Don't need okay. Well, let's try to run the tests and see if that is working. Okay, but I don't actually know if we are here at all. So let's try to do something like that. And that should tell us if we are ever in this branch. Well, we are at least in here. So that's good, I guess, but we are not really in the real code. So let's continue doing this refactoring. We can replace it with this thing and say temp, right? And things did not go well now. So one thing that could possibly be going on, I think, yeah, because I forgot to release it. So maybe that's the issue. Yeah. Well, at least it's good that I can catch it somehow with the test. Yeah, there is also this whole thing that I did yesterday. You can take a look at the commit. Basically, this is a very bad version of memcopy that is necessary for being able to return sort of structs by value from functions. And again, it's all very, very inefficient, both this thing and how we return structs and everything. But I just wanted it to work. And here, I think it's a very good exercise to actually verify how all of this works, because we need right now I'm using 3 stack locations, but it's probably possible to use registers instead. So, okay, let's try to change that then. We can do value register for descriptor. And then here will be this temp register acquire. Okay, and we need to not forget to release all of them. So yeah, I think I will even wrap it in another stuff. It also might be worse to add a helper that something like with register that will automatically release it at the end using a for loop or something like that. I don't know how convenient that will be, but we'll see. I will do more of this refactoring outside the video, and then it will be visible if that is something that makes sense. So that should be what I want. Yeah, so this is temp RSI, temp RDI, and temp RCX. Cool. Let's see if that works. It does, but I also wanted to show you how it actually looks like now. No, don't recover. I don't know. Let's check that we are in the right file, because yes, they had to change it a few times. Okay, yeah, so this is the test. As you can see, we have a 128-bit struct that has two S64s. And according to the calling convention of Windows, we are passing a pointer to where the struct is going to be located, then we're copying it there. So let's see what we have now. That's not what I wanted. I want to go here. Let's go inside the call and let's look at this. And here you can see this stuff, right? So I need RSI, RDI, and RCX to be free. And now I'm moving them inside RAX, RCX, RBX. And then this is the copy. So yeah, very basic things seem to be working. I don't know how much stuff will need to be done to actually make it robust. Obviously, there is this. Right now, I think I can remove this fix me because we did fix it, which is nice. But getting back to here, we obviously have two issues. One issue is that we if we run out of registers, we don't know what to do, and it is probably possible to run out of registers right now. If we have complicated enough expression, but that I will need to figure out a test for that. So this is something to think about how to do this. And then the extra thing is sometimes it would be nice to have a helper that basically tries to acquire a very specific register, but then it's unfortunately C is very bad at helping us track that. So it would be nice if I could just say, oh, give me a RSI, and it will take what is currently in RSI, it will put it in a temporary storage like we do right now, and then put it back. But this is not something that is very easy to do. So for now, this unfortunately is out. And honestly, I don't think there is much more to it. majority of work was preparation for this stuff. And now the main part is we can get registers. I will go through this whole program and basically just beautifully replace all the hard-coded registers with acquiring and releasing temporary ones. So hopefully that will not break anything. It will just make it a bit more robust. But there is definitely more work to do at some point. Right now, I wanted just to have something that I can rely on, and if it fails, at least I can see that it fails. Because previously, like right now, I wouldn't mind that we would get that crash right here. That is perfectly fine to me because I will know that I'm doing something weird. Whereas previously, the big problem of not having any allocation and tracking at all was that I could accidentally stomp on a value that is actually valid and not realize that that's happening, and that's not great. So this tracking of register is a big step forward, even though it took like 10 minutes to actually build. So yeah, I guess that's it for today. There is a very big refactoring in front of me. If you want to follow that, I will put a link in the description to the repository as usual. And yeah, thank you very much for watching, and hopefully see you next time.